friends, welcome to this video. Here we will be discussing derivative of parametric functions. So first of all, let us try to understand what is a parameter and what are parametric functions. Sometimes variables x and y are expressed in terms of some third variable, let us say t. As for example, let x is a function of t and y is another function, g function of t. Then here this t is a parameter. Then t is called a parameter, and these functions ft and gt are known as parametric functions. If x is equal to a cos of t plus log of tan t by 2 and y is equal to a sin of t, then find derivative of y with respect to x when t is equal to pi by 4. So first of all, we will get the derivative of x with respect to t and derivative of y with respect to t. So derivative of x with respect to t, that is a is constant here, d dt of cos of t plus log of tan t by 2, and this is equal to a. So these two terms will be differentiated separately. So a d dt of cos t plus d dt of log of tan t by 2. This is equal to a. You know, derivative of cos t will be minus sin t. So this is minus of sin t, and here we will apply function of function, chain rule, because this is logarithmic function of this one, and this tan function is itself is a function of t. So first of all, we will differentiate each log tan t by 2 with respect to tan t by 2. So differentiating log of tan t by 2 with respect to first tan t by 2 into derivative of tan t by 2 with respect to t. Now this is equal to a minus sin t plus derivative of log theta is 1 by theta. So we can write here this is 1 by tan theta by 2, and derivative of tan theta by 2 is sec square. So sec square t by 2 and into again t by 2 will be differentiated with respect to t. So this will be equal to half, and this is equal to a minus sin of t plus, you can write sec square as 1 by cos square and tan as sin by cos. So, and this is 2. So this becomes 1, 2 sin here t by 2. Sin t by 2 into the, from here we will get cos of t by 2. And this is equal to a minus sin of t plus, using the formula 2 sin theta into cos theta, sin 2 theta. So this can be written as 1 by sin of t, and this is equal to a 1 minus sin square t upon sin t. This is equal to a cos square t upon sin of t. So this is the value for derivative of x with respect to t. Now, with the help of this expression, we will get dy by dt. This is y. So derivative of y with respect to t, this is equal to a d dt of cos of t, and this is equal to minus a sine of t. So now we have to find out derivative of y with respect to x. As we have discussed earlier, this will be equal to derivative of y with respect to t upon derivative of x with respect to t. So derivative of y with respect to t is minus a sine t, and derivative of x with respect to t is a cos square t upon sine t, that we can write here, sine t. This is equal to minus a tan square t. Now finally, we have to put the value of t is equal to pi by 4. So therefore, derivative of y with respect to x at t is equal to pi by 4. This is equal to minus a tan square pi by 4. So answer is minus b. This is the answer. Since tan pi by 4 is equal to. So in this way, we can differentiate parametric functions easily. Let us see one more question. If x is equal to a 1 plus t square upon 1 minus t square, and y is equal to 2t upon 1 minus t square, then find derivative of y with respect to x. So with the help of this expression, we will try to get dx by dt. Before that, we will simplify it, this expression. So we can write here x is equal to a. We can write this expression as minus 1 plus 2 upon 1 minus t square. You see, after simplifying, we will get the same expression in numerator also. This will be minus 1 plus t square plus 2, 1 plus t square. And this is equal to a minus 1 plus 2, 1 minus t square whole to the power minus 1, 1 minus t square in the numerator. So therefore, dx by dt can be written as a derivative 1 is 0 plus 2 by the formula derivative of x to the power n will be n into x to the power n minus 1. By that formula, we can write 2 into minus 1, and here minus 2, power will be minus 2. So we can write 1 minus t square in denominator square, and again minus t square will be differentiated with respect to t. So that will be minus 2t, minus 2t, and this is equal to a. This is 4t upon 1 minus t square whole square. This is the value for dx by dt. Now let us find out value of dy by dt. Here y is 2t upon 1 minus t square. So derivative of y with respect to t, we can apply quotient rule here. So denominator into derivative of numerator minus numerator derivative of denominator upon denominator whole square. Now simplify it. So this is equal to 1 minus t square into derivative of 2t is 2, and here minus 2t, and let us find out derivative of 1 minus t square. Derivative of 1 is 0 and derivative of minus t square is minus 2t upon 1 minus t square whole square, and this is equal to, we can take 2 common here, so 2 1 minus t square, and here we are getting plus 2t square plus 2t square upon 1 minus t square whole square. This is equal to 2 1 plus t square upon 1 minus t square whole square. So this is the value of dy by dt, this is the value of dx by dt. Now we have to find out dy by dx. So we can find out easily, as dy by dx can be written as dy by dt upon dx by dt. And dy by dt is this much, 2 1 plus t square upon 1 minus t square whole square, and dx by dt is this much. So in reciprocal form we can write 1 minus t square whole square divided by 4t into a. A is here. Now you see, we can solve it easily. This will be cancel out, and finally we are getting 2 1 plus t square upon 4a t. This is the answer. So students, please do some more practice to command over this topic, and I hope you might have got benefit from these videos. So please subscribe my channel and share these videos with your friends also, so that they could also get benefit from it. Thank you very much.